Good day, everybody. Bonjour. So nice to see you all at ECC Week 2023. So my name is Paige Donner, and welcome to Tooling Open Science with Web3 and the blockchain. So what we're going to be talking about today is more open science, so science ouverte. So I know that a lot of us here in this room are very familiar with DeSci, and I'll be addressing what some of the differences are between DeSci and open science. But just to start off with, I would say that science ouverte, or open science, is a really big umbrella, and it allows all kinds of thought and all kinds of people and all kinds of backgrounds to participate in science. So just a couple words about myself. My name is Paige Donner, and I'm the co-founder of Frontier DAO. So Frontier DAO is a science-focused DAO, and we were founded in 2021, August 2021, and our verticals are fusion energy, space, and climate tech. So we're a little bit different from some of the other DAOs in that we don't touch at all on pharmaceuticals or biomedicines or things like that. I'm also a small business owner, so my company is IoT Logistics, and it was actually through IoT Logistics that I got involved with blockchain, and it was actually through using blockchain as a utility for supply chain, and that was in 2018. And I mention that because it's a woman-owned small business, and while I live in Europe, my company is actually based in the United States, and it's qualified as a government contracting company. And so through that company, I'm actually a subcontractor to NASA on a STEM Inclusion Award, which kind of keeps me current on what the government is doing in terms of contracting in science and R&D. So there's some of my contact. There's the website, frontierdao.xyz, and I'm also the builder and creator of Frontier Registry, which is an on-chain science publishing protocol, which I won't go into too much today. I'll just mention it towards the end. Today's agenda is actually, I'm gonna do this presentation for about 20 minutes or so. We're just gonna run through what some of the state of open science today. And then I'd like to open it up for the second part and do kind of more of like a workshop. So Q&A is great, but I'd love to see us all sort of form maybe little groups of maybe 4 or 5 and do some kind of workshopping ourselves on how can we solve for some of the pressing scientific needs of today using some of the blockchain tooling that I think probably everybody in this room is very familiar with. Okay, so I mentioned that I am a subcontractor on a NASA award. It's a STEM Inclusion Award. And that's why I'm very cognizant of their TOPS program. So NASA TOPS is Transform to Open Science. And the program was stood up in mid-2022. It was funded with about $42 million from the US government. And I'll go into it in more detail in the coming slides, but the White House did actually acknowledge or announce that 2023 is the year of open science. So NASA as an agency tends to be sort of one step ahead, and so they've already been tooling and creating some of these toolkits and workshops and information and how can people get onboarded. So let's just go through some of the basics of what is open science. What are we talking about when we say open science? Now, the most important part, the 4 most important tenets of open science is that it's transparent, it's inclusive, it's accessible, and it's reproducible. So let's dive into those just a little bit. So open, transparent science that means the scientific process and results should be visible, accessible, and understandable. Open, inclusive science. So the process and participants should welcome participation by and collaboration with diverse people and organizations. I want to underscore that a little bit because a lot of times in global conversations, I mean, sort of like the meta conversations of inclusive, I think a lot of times we think that we need to share the results of what our findings are. But actually what inclusive is really speaking more to is to share the process of how we get to those results. Open, accessible science, so data, tools, software, documentation, and publication should be accessible to all. Fair is probably a term that a lot of you are familiar with. I know Martin is probably very familiar with the term fair, which relates to data, findable, accessible, interoperable, and reusable. I gave a shout out to Martin because he's with Flamingo Protocol, so he's at the cutting edge of a lot of this stuff. And then reproducible science. So I know that all of us in this room are probably somehow engaged in science, so we're very well aware of the reproducibility crisis. So scientific process and results should be open such that they are reproducible by members of the community. So if you have some kind of cutting edge breakthrough and you go, hey, I cured cancer, that means that you should be able to go in, look at all the data and go, hey, yeah, he did, because I was able to reproduce it, right? So, okay. So a little bit more about TOPS, and there is a QR code there if you guys want to click on it. That'll take you to their GitHub repository, their toolkits. They've got all kinds of, they're just great about creating really good information. So their 5-year plan is to accelerate open science practices. So the roadmap is to enable 5 major scientific discoveries through open science principles, broaden participation of historically excluded communities, so that means double the participation of these groups across NASA science. TOPS is actually housed in the Earth Sciences division of NASA, but it touches on all the different areas of NASA. Increase understanding and adoption of open science principles and techniques. And I love this one, support 20,000 researchers to earn NASA's Open Science Badge. So it's a very interactive toolkit and platform that you'll see that's still being developed, but it's really picking up steam now. So go and check that out and start getting your badges. And then accelerate major scientific discoveries, yeah? So that's their roadmap. So this isn't a whole a presentation about NASA, but one more point is that this is actually a slide that I sort of took off of their program scientists. Their program scientists, her name is Shel Gentleman, and if anybody attended Meta Science a few months ago, I know a few people from Protocol Labs actually spoke. 1 or 2 people from Protocol Labs also spoke there, and Shel spoke there as well. So she's the program scientist of TOPS. And, you know, again, it's like open science is accessible, reproducible, and inclusive. So it creates research that it's cited more, it has a bigger impact, it increases transparency, it's more inclusive. What does inclusive science mean? More collaborative projects. There's access to hidden knowledge. Right, so even a lot of times when data is made open or open source, it still can be kind of hidden, right? It's kind of like you need to know where to look for it in order to find it, even if it's open. Equitable systems, increased participation. So by increased participation, we do mean citizen science, but we also mean all kinds of increased participation. So, infrastructure, funding, policy, and outreach. These are some of the areas that have been identified as where we really need to start working on being able to not just communicate about open science, but actually implement it and build the tools to implement it. So again, we need more people, more hands, more eyes, more brains. We need more people with diverse experiences to participate so that we ask the best questions and find the best solutions. And again, these aren't my quotes. I'm quoting from some of the top people in the industry, Yale, Harvard, MIT, NASA. So let's talk a little bit more about infrastructure, funding, and outreach. As I mentioned, the excuse me, the U.S. government declared this the year of open science. So in May and June of this year, so just like last month, they held a series of listening sessions. And it was kind of a very interesting process. The White House Office of Science and Technology and Partnerships, they actually held weekly, or over the course of 2 weeks, they held twice weekly Zoom meetups, and anybody could sign up. It was open to the public. They even had sessions in Spanish that were translated. So they really tried to make it open and welcoming to all kinds of people who were offering their feedback. And a lot of it was geared towards early career researchers. Because what we're seeing is that as we put together these policies of like, hey, let's do open science, let's adopt these open science policies, what we're also finding is that actually on a systemic level, sometimes that's harder to implement than it may sound, right? So we want to be collaborative, we want to be open, but then when you're maybe an early career researcher at an academic institution, you may have rules and regulations at your own institution that prohibit it, or in some cases actually make it regulatorily unfeasible, if regulatorily is a word. So I've just noted some of for the Americans in the room, you'll recognize some of these logos here, but these are some of the biggest US agencies. There's NOAA, there's GSA, there's the Smithsonian Institution, National Science Foundation, NIH, NIST, USDA, so all kinds, Department of Commerce. And if you go onto openscience.gov, you'll actually see a listing of not just a list of the government agencies, but actually the actual programs that they're implementing to carry forth open science. And they've all initiated actual programs and roadmaps. So it's not just NASA. Now, this is not just a US thing. Now, I'm actually based here in Paris, so I'm kind of aware of what UNESCO is up to. And UNESCO is actually all in on open science. It's really, really exciting what UNESCO is doing. So the UNESCO Open Science Toolkit is designed to support implementation of the UNESCO recommendation on open science. So the recommendation on open science is the first international standard-setting instrument on open science. So this recommendation was adopted by 193 countries in November 2021 at the 41st session of the UNESCO General Conference. And their toolkit is easily accessible on their website. And it kind of dovetails a little bit with the NASA toolkit in that it sort of walks you through, okay, if you're a teacher, or if you're an academic, or if you're a researcher, and you want to start practicing open science, then these are some of the things that you can follow. These are some of the I don't want to say protocols, but these are some of the guidance and the measures and the practices. And I also, we're here in France, so it would be, it just wouldn't be right to not mention the CNRS. So the French scientific research organization at the national level also has a plan for open science. And this quote here, open access makes the movement towards disseminating scientific production on the internet possible, that actually comes from 2015. So open science isn't a new thing. Open science is a thought and a movement that's been around for over a decade. It's just that we've been, I think, kind of struggling with how do we implement it? How do we have the tools to actually be more collaborative, be more sharing, protect people's IP, have data that's open. I actually really love this quote, as open as possible and as closed as necessary. So the European Commission report on 2016. So again, that's from the CNRS. And I'd also like to mention, because this actually just happened and it was very exciting, and it'll seg very nicely into what we're going to be talking about in terms of open source software and open science can actually sort of really support one another and feed into each other. Just last week, so the 10th to the 14th, NASA and CERN, so CERN is of course the nuclear regulatory agency down in Geneva. They teamed up and did a whole week-long summit on accelerating access to open science. And they had people, it was open to the public too, if you wanted to participate virtually, which I did, it was free. If you wanted to go there, you could go there as well. But what was so great, and I think what is so significant about that is we need to remember that CERN is where Tim Berners-Lee worked as a nuclear physicist when he decided, or when they as a team decided, to make HTTPS public, right? Would we, ladies and gentlemen, would we have the internet as we know it today if HTTPS hadn't been made open source, public, and free for everyone? So that history, I think, is very significant, and it's also been transformative for 5+ billion people around the globe today, right? More than 2/3 of the world's population rely on their internet for research, commerce, entertainment, and communications. Okay, so I think that's kind of where we're at. We're at the point of like, if we're going to start using blockchain as tooling, then we need to think about what's come before us. How did they implement governance when we were talking about this new thing called HTTPS? And it feels like, it feels like 15, 20 years ago was a long time ago, but I'm old enough to know that that really wasn't that long ago at all. So here's just some additional resources. There's great resources out there, but open source science white paper, of course the Jupyter notebooks, probably a lot of you are familiar with the Jupyter notebooks and lab. 2ITC, another great organization. NumFocus is teamed up with IBM, and NumFocus is also, Jupyter.org. And I really like this quote by Alexei, who works with both NumFocus and the Open Source Science, which is kind of they're sort of the same organization. Science and technology. Okay, so we aspire to convene these two great community efforts of the modern era by bringing together scientists and technology developers to drive a new open era of progress. So how a lot of people are looking at this nowadays is that we're not really going to have open science unless we actually figure out how to best practices implement technology along with it, right? Because it's all about data. It's not all about data. A large part of it is data. Okay, so here we are at blockchain. So, home at last. I know this is a blockchain conference, so tools for open science. So, here I'm going to mention just very briefly on only one slide our project, which is Frontier Registry, and I mention it because open science is a nice idea, but how do we implement it? So at that CERN NASA conference last week, they had a whole morning devoted to open source software and how open source software can actually work to be the implementation tool for open science. And I couldn't agree more, actually, because right now, what a lot of the people in open science are saying is that, okay, we have policy. Actually, this is kind of what they're saying. Anna Persick, who runs the UNESCO division on open science, she says, we have infrastructure. So look at it as a pyramid, okay? We have infrastructure, then we have capacity building, then we have incentives for the scientists and the researchers, and then we have policy. And right now what we have is we have policy at the open science level. From the blockchain perspective, we have all kinds of infrastructure, but it's not being used or applied towards open science yet. Now, I think that that's maybe kind of where DeSci comes into the picture, right? Us DeSciers are some of the first people who are kind of trying to mastermind how can we use these blockchain tools to carry forth openness, inclusivity, accessibility, reproducibility, right? Transparency. So Frontier Registry is in an alpha release. It's the on-chain scientific publishing platform that we built. and it's just in alpha release. We got a little bit of a micro grant from Polygon, so it's just on the testnet now. And then we're looking to build it into beta, but it's basically on-chain publishing, right? So if you're a researcher and you're like, okay, I just had this really great breakthrough, and I want to collaborate, but I don't have the $15,000 to pay Nature or Springer or Elsevier to publish my research. But I want to show it to my colleagues. I want to get their feedback. So what do I do? Do I just put it do I put this cutting edge research in a drawer and let it not see the light of day because I need to protect my IP, which is reasonable. I don't find any fault in that, actually. But if we have tools that allow researchers and scientists to actually share their work in a way that protects their IP and makes it so that they will be recognized, rewarded, and have attribution for their work, then let's do that. Let's do that, because I feel that is what's going to open up the floodgates of collaboration. And that's what we're trying to do with Frontier Registry. There's a video. I'm not going to play the video right now, but so open science and blockchain, and then DeSci. So I would say that DeSci, or decentralized science, so I think the term DeSci is still being defined by the ecosystem. So it often right now implies the use of DeFi tools such as tokenized data, but it's a very young movement. It really only gained traction from like ETH Denver 2022. When I published Frontier Registry as an IP NFT, that was February 2022, and DeSci was not yet a trending hashtag. In fact, it wasn't even a hashtag. So that's how young this movement is. Blockchain for science, I think, has been a concept that has been thrown around for a little while. And again, blockchain tooling for open science implementation, so more broadly interprets uses of the blockchain for scientific research and sharing, such as, like we discussed earlier, FAIR, findable, accessible, interoperable, reusable. So again, I think I'm not really trying to, compare apples and oranges, although I wouldn't call DeSci and open science apples and oranges. I'd call them kissing cousins, really, actually. I would say that they can really be very supportive of one another, and one can help accelerate. I think DeSci can help implement open science, and I think open science can help legitimize DeSci. Because a lot of the things that I'm finding as I try to bridge the two worlds of, say, being a government contractor and then also being part of the blockchain ecosystem, is that sometimes buzzwords can have different reactions, right? So sometimes if you say DeSci, people are like, is that DeFi? I mean, what, and then sometimes the brain will just kind of like shut off, like, ooh, that's not something I don't want to get into crypto. I'm a scientist, right? But then when you talk about open science, there's a very strong recognition nowadays that in terms of implementing open science, new tools are going to have to be not just created but actually used. So, okay, sorry. All right, so enough of me talking. What I'd love to do now is, actually, if it's okay, I would like to have us break into a few groups, and I did bring some pens and some bits of paper. And what I'd love to do is to see if amongst yourselves, like maybe groups of 4 or 5, we could sort of just do maybe a 5-minute or so brainstorm amongst yourselves to choose some kind of a scientific need. Cure cancer is always an easy one, but climate relief, energy justice, replanting wildfire-devastated lands could be something, or maybe you're already working on something very urgent that you could try to solve for, and then we can meet back after a bit of a collaboration. And I think what we'd like to do is try to solve for accessibility, transparency, reproducibility, and inclusivity. And maybe just to spark a little bit of thought, what we're doing at Frontier DAO is we're trying to actually solve for energy. So our big vision is fusion energy, and what we'd really like to see is to use the blockchain tools to democratize energy, right? To actually render energy as a public good, and we feel that fusion energy holds that promise. I'm not going to go too deep into the weeds about fusion energy because that's its whole own subject. But let's just say that what we're trying to do is systems engineer so that bits and bytes become friends with atoms. So, and it's just all about accelerating research and collaboration through open science tools enabled by the blockchain. Yeah. Okay. So, let me stop. Let me go back to that slide. So, can I do a time check? I was just going to do like a quick time check because I'd like to break the room out into like small groups just to. Oh, 13 minutes. Okay. All right. Cool. So I have some pens and I have some paper. If you might want to just you could even just turn to your neighbor you can maybe just turn to your neighbor in your chairs, and I've got some pens and papers. If you'd like to just come up with one or two suggestions as to what aspect of blockchain would you use to solve for what problem do you see in scientific research, thinking with the guiding principle of accessibility, transparency, reproducibility, and inclusivity. Or maybe there's questions first.
If you have a question, just raise your hand and we will give you a microphone. One second.
I had questions about the incentives because, well, I'm not really a specialist of research in general, but as far as I understand, most of the research is privately funded. And I was wondering what were the incentives for private institutions to go into open science or to use blockchain? Because it seems like it's pretty good for non-profit organizations, but maybe less for the private sectors, but I don't really know.
Yeah, that's a good question. Well, I think open science is going to touch on the private sector differently from the public sector. Some of the use cases that I was bringing up are actually federally funded research institutions. And so in the United States, we actually have a mandate. And also, for example, CERN works under this ITER, which is the big fusion conglomerate down in Provence here, which has 37 countries as its collaborators. They're all under regulation to actually share their data. So, for example, in the United States, any federally funded research has to be made public. So you're bringing up a great example for private, but I think that would be a little bit of a different conversation if we're talking, say, I don't want to name a name, but like a big pharmaceutical or a big, yeah, good point. So I've got some papers, and I've got some pens. If you guys just want to kind of collaborate we'd have like 5 minutes, and then maybe come back to the group and see if you have any suggestions.
if somebody
Yeah. Define the problem and then try and find it or suggest a solution or brainstorm about a solution. Yeah, and basically, yeah, just do whatever comes up. You know what I mean? Like if you're a researcher at an academic institution and you're like, oh, I need to publish this, but I don't want to wait 6 months for a legacy publisher to actually give me the go-ahead. How would I use blockchain to publish my work, but also make it, protect my IP? Yeah. Vous parlez français peut-être? Ah d'accord, ok. Bah,
if somebody don't have a pencil, tell we will give you a pencil.
Ah, ok. C'est un petit atelier, donc c'est juste un atelier de pensée, la façon de faire faire la recherche scientifique, mais avec les outils de blockchain. Donc, mais on pense en même temps aussi de accessibilité, transparency, transparence, thank you Bertrand, transparence, inclusivity, and reproducibility. Yeah, si on peut penser un peu de ça. Et reusabilité, oui, c'est vrai. Reusabilité, oui, tout à fait. Yeah. Hey, how's it going?
Good.
Oh, good.
The activity, I've not seen a lot during the activity during the presentation. So it's maybe we to be more specific. I feel it's too wide. Maybe that's the purpose, but
Well, you could think about in your line. You could think about like regenerative, like a regenerative issue, like maybe replanting trees or something. How could we use the blockchain to replant trees? Because earth science is a big part as well. Yeah, you should maybe team up with him or something, or them. Yeah. Oh, good. No, c'est bien, c'est bien. Oh, perfect. But for the sake of conversation, it's important because probably many people who are going to it may be something you know, but it's probably not something that a lot of people know. Yeah. So it's good. Do you need a pen? Okay. Hey, how's it going? You're solving all the world's problems. Okay, cool. Yeah, I don't want anybody to give away their best ideas, but I just thought it could be good for conversation and to get people. Yeah, true. Oh, okay, all right. Okay, all right. So I'll probably wrap it up in maybe. So, How about one more minute, and then we'll reconvene and maybe share some of what we were working on together, just for like the final 5 minutes. Oh yeah, yeah. Yeah. Oh, right. Yeah, I gotcha. Okay, I'm sorry. Okay, all right, thank you. Do we have a time check?
Yes,
Or?
I have a time. 24. We have 16 minutes more.
Oh, 16.
16 until 15:40.
Oh, perfect. Okay, all right, so we're good.
But to have a conversation, it's with the yes. This is
The next one starts at.
the next will start in 3:45.
Oh, okay, so.
15:40. Yeah. So we have so we will need to have kind of several minutes that this speaker prepare
Yeah.
his presentation. To.
Okay.
Yeah. So until 15:40, we can be.
Here.
Here, yes. If it will be 1 or 2 minutes more, not a problem.
Okay. Okay. Perfect. Perfect. Okay, so maybe we'll come back together as a room, and maybe share some of the stuff that we came up with. I know that some people were thinking, I think some of what we fall victim to in the blockchain space, to be honest, is that we get so familiar with all of the tooling that we know about, and we forget that we are a little bit in a bubble. Like we are kind of experts on certain things, and we forget that there's like a whole world out there that actually doesn't know about this. So if you think that you didn't come up with something brilliant, I bet you did. I bet you what you came up with is going to be brilliant for a lot of people out there. So let's start sharing the mics. Who wants to talk about what they came up with?
Somebody want to start? Just raise the hand.
Hi, so I wrote three things to talk about. First one is coral bleaching due to the temperature who are going up. The second one is carbon released by the permafrost, same thing. And the third one is a bit different. It's Lyme disease due to tick expansion. So yeah, 3 things to debate.
Did your team come up with any ideas about how to use the blockchain to tool any of that?
Not directly here, but I have some ideas for some of these points about coral bleaching. Some companies are working on it to create like hybrid corals who can support more than 2 or 3 degrees. About the permafrost, it's other people are working with an old cow. I don't know in English, but it's the auroch and the yak. Okay, so and they're also working. Is the reason a lot of people are working on the mammoth. I don't know in English how we say mammoth. Maybe same word.
Mammoth, the ancient.
Yeah. And because it's one of the idea because they can hit a lot of lands, they can keep the permafrost iced, and so the carbon release will be lower. So some scientific are working on it. And about the tick expansion and the Lyme disease, it's a big problem for a lot of people, and I don't have. I don't have the solution. So, yeah.
Excellent.
Hi, we are Lip Science. And we are currently building with NRIA support university, French university, a solution who is answering that was you're asking now. So we are actually building a system to allow actors of research to publish with blockchain and to share their work openly. Yeah. So there is a lot of blockchain tools used for that, and it's pretty long to just enumerate them.
Okay, all right. So I understood that you were saying you work with a big academic institution, and your company is Libre Science, so kind of like Liberté Science or Libre Science, free, yeah, okay, open science, and that you're recognizing that using blockchain tools for publishing is a very great way to implement. Okay, understood, great.
Yeah.
The idea we had was more around allocating funds. So if you take decentralized autonomous organizations, you could think about putting the funds in one of them and then thinking, how am I going to give votes to different actors to make sure the funds are allocated in the most optimal way. So you could say, well, people that put funds gain votes, but you could also say people that contribute to the objectives of the organization and that are validated by peer review gain votes on the funds too. So it's not anymore only the people that put funds in it, it's also the people that contributed the most towards the objectives. And so you could think that it might push influence towards skilled and knowledgeable people that are validated by their peer, basically. But that would probably be a really ambitious project. But yeah, that would be interesting.
Yeah, great. So I understood you to say to use a DAO structure so that people can actually participate as contributors in a monetary sense, but also in effort and in skill and in talent, right, into the collective, and then thereby have governance into what next research gets done or what project gets funded. Was that correct?
Yeah, exactly. Yeah, that's the idea.
Excellent. Yeah, that's a very alternative methods of funding is a very exciting element of what blockchain unleashes. Absolutely. Yeah. Who else?
Was me or someone else? So we figure out that the data storage using the blockchain technology is actually a very resilient one, and maybe it could be used for things like storing data that cannot be tampered and must be secure. So, for example, either medical data or just vulnerable scientific data, like data about humans. It could be stored on chain. Not stored on chain, for example, stored on IPFS and then anchored on chain. So these new technologies allow creating these systems for storing data very securely. And the same thing could be used, for example, for the proofs of authenticity of the papers. So, for example, if you find a paper, you know that this is actually the version which somebody posted and it was peer-reviewed, and it's the real thing, and it's not just some copycat or just some fake information. So this is for the data storage, and the other idea we had was about the patent pools, where they can be much more transparent and much more accessible when they are, for example, tokenized and stored on chain, because then it's very easy to track the ownership. So it's easy to prove that actually I have access to this pool. But on the other hand, it's unstoppable, as in anybody can buy it. So it's no longer a gated castle full of lawyers who are giving away or not giving away the rights. It's just like anybody can just go and buy a share. Yeah, so this could also make it more transparent and more robust. So yeah, these are the ideas.
Excellent. Yeah, those were all really excellent points. I know we're running short on time, and I think one more person had something to say.
Okay, so you guys are neuroscientists, and I'm an economist. I don't know if you're okay with that.
Great.
My suggestion would be something that I've been thinking for quite some time. There is a thing called complementary currencies, and these are currencies that act as an enhancer of local economic activity. And perhaps with the implementation of token-based systems like CBDCs, you could create a tokenized monetary policy that is based on a jurisdiction. So in theory, if you want to increase the development of agriculture in a region that doesn't have financing, you could create some sort of economic incentives that increase the velocity of money for those tokens within jurisdiction. Or if you want to increase wealth creation within a jurisdiction that doesn't have enough money, you can create super sound money, which is deflationary theory, to be what these people have. But you can continue that without needing any additional exchange of that token. It could be used outside of the jurisdictions, just like a dollar or a euro would be. And theoretically, that could help make a much more flexible monetary policy, incentivize people to grow regions that aren't developed or have been stagnant, and you can share that data publicly to try to see if you can create a localized monetary policy. That's something that I believe you could use tokens and blockchains for, and it is scientific research if you count economics as science. I don't know if anybody here doesn't. Some people don't. That would be my suggestion.
Sure, great. Yeah, economics is, of course, a science. Political science is a science. Social science, yeah, excellent. And I like how you used agriculture as an example, but I would imagine that what you were just putting forth could be used for any kind of a subset, whether it's neuroscience or climate technology, or it could be any jurisdiction, really, right? Cool. I think we may be out of time.
Maybe
I think we might be.
a last one.
Anyone last one?
Probably me.
Oh, good. Yes.
To do peer review, you need reviewers, and to have high quality, high skilled, experienced reviewers, it's very difficult.
Yeah.
Myself, I've been asked to be a reviewer by many papers and conferences, and I can't accept because I don't have that much time, and it's not good. It's not rewarded my time. So how to create an incentive for that? Probably we could use blockchain to trace any review, and moreover, when you do peer review, you may have an interaction between the researchers that publish the first iteration of the paper, and if you could trace or track any constructive review and give an incentive to take time to make a constructive review and not just make a very fast one because you have to do it, then you would have something that is more valuable to improve the final paper. And if you have a better, it would lead to better result at the end, a better paper. If you can use blockchain to track all contribution from the reviewers and reward them by having them on the final paper. And then also think about how to give an incentive to transfer that to the industry in a proper way where it's easy to use to solve real life problems. And so if you can track the contribution all the way from the beginning of the research to the participation of the reviewers until you make it usable for the industry, then you could automatically reward all the contributors from the beginning of the chain. And blockchain can be useful for tracking all this and have a distribution key that is decided collectively and automatically reward everyone.
Yeah, Yeah, great. That was great. Oh, great contributions. And the last, if I understood you correctly, it's that peer review gets absolutely no reward. There's no incentivization for it. It's a hard job, and it's also unrecognized. And so, one, to incentivize it, but also to recognize it with some kind of attribution, or as we were talking about in open science, it means to acknowledge the collaborative effort of all. Yeah, great, awesome. I want to thank you all very, very much for this Science Ouverte session, and couldn't have been done without all of you, so thank you so much for all your great contributions.
Thank you.